Okay, so we're looking at the second year Stats and Mechanics textbook, and we're on chapter 6, which is projectiles, and we're on the last exercise, so that's exercise 6D, which is on projectile motion formulae. So it's quite a tricky one, this one, but it's a good chance to practice that you really have thoroughly understood this idea of horizontal and vertical motion, and good test of your algebra skills as well, and your trig. So let's see how we go. Okay, right, so question 1. So got a particle that's launched with an angle of elevation of alpha. So basically they're not going to give us any values. That's the main point of this exercise. Everything is just going to be in general rather than having actual values to calculate. So it's angle of elevation alpha and an initial velocity of u, capital U, meters per second. Okay, and this one is asking us about the greatest height. So if we think about what's going to happen if you're just projecting something up, it's always going to follow, assuming it doesn't sort of hit anything on the way, it's going to follow that kind of shape. So we are after the greatest height. Well, what is special? How are we going to identify that? Well, that is going to be, so basically if we think about its vertical motion, it's going up, 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 but slowing down due to gravity, and then it reaches its maximum height and then starts coming back down. So at that point there, it should be the initial. At that point there, the vertical velocity, so I'll use v for velocity and then subscript v for vertical, is 0. So you've used that in plenty of other questions. Now we're just using it in a general formulae one. Okay, so that does come up a lot. So it's at its greatest height when its vertical velocity is 0. Okay, so then let's have a think about how we can use that. So I think for this question, I actually only need to consider the vertical motion. So that's quite nice. Okay, so vertically, the initial velocity, so let's label that up here. So the initial velocity, so you've done this a lot, you did a lot of practice of this in exercise 6B. So the initial velocity vertically is capital U, and so that is opposite angle alpha, so that's going to be capital U sine alpha. Okay, so that's the initial vertical velocity. I want to know when the vertical velocity is going to equal 0. I know the acceleration, so if ever I'm looking vertically, acceleration is just going to be g, but I just need to be ever so careful. I'm taking up as positive, yeah, because it's that initial velocity is upwards, so that means acceleration is going to be minus g, and I'm going to use minus g rather than minus 9.8 because we are, as I said before, we're talking generally here, so we're not giving values for u, we're not giving values for alpha, and you can see there's a g in the final solution we're trying to get. And actually we can also see there's a sine alpha, so that's quite good. Okay, and I want to know the maximum vertical height, so that's going to be the displacement, and I'm calling that h. Okay, so which of the Suvat equations am I going to use? Well, if I've got those 4, I'm going to use v squared equals u squared plus 2as, and there is some stuff that's squared in there, so again, that's looking hopeful. So vertical velocity is 0, so that's going to be 0, I'll put the squared, it doesn't need to be there. So 0 squared is the initial velocity squared, so I'm going to be really careful and have some brackets there. So the initial vertical velocity is u sine alpha, plus 2 times a, and a is minus g, so that's 2 times minus g. If you automatically put the minus there, obviously that's absolutely fine, and then times s, so of course just use different colour highlighter for each of these, never mind, and s is h. Okay, so that's, I'm feeling quite positive about this because I can sort of see where a 2g is going to come into things. I can see where u squared and sine squared is going to come in, so I think we might be there. So let's just tidy all that up. So 0 squared obviously is 0. If I want to lose those brackets, that's going to be u squared times sine alpha all squared. But you know from your trig that when you're writing sine squared or cos squared, the convention is to write the squared there. Yeah, so from your identity, cos squared x plus sine squared x equals 1, you've used that quite a lot. And then if I move that minus out to the front, that just becomes minus 2gh. So yeah, pretty sure we're there. If I add the 2gh over to the left-hand side, if I then divide through by the 2g, struggling to write my squares for some reason. Oh, if I move up so you can actually see it. So that's all over 2g, and then we breathe a huge sigh of relief because that's exactly what we wanted. So as it's a proof, I'm just going to put as required. Okay, so job done.